International presentation on process control tools for the hybrid, LTCC, and MLCC industry. This short video will discuss some revolutionary new products for process control and process setup. A combination of PowerPoint slides and actual ScanCAD software will be utilized during this presentation. We think most of you will agree that process control means no surprises. Typically, in a manufacturing facility, a surprise is a bad thing, so the more surprises can be avoided, the better. The first part of this video will briefly discuss ScanCAD International, the company, and today's challenging hybrid manufacturing environment. Most of you are very familiar with the hybrid manufacturing environment, but this discussion will help to set the stage for a discussion of some new tools from ScanCAD, designed to assist manufacturing facilities in setting up new processes and keeping existing processes running smoothly. In other words, minimizing costly rework and production line downtime. The second part of the video will describe the actual ScanCAD International pre-production and production process control tools. ScanCAD International has been providing solutions to the electronics industry since it was founded in 1990. ScanCAD products have actually been around since 1987 when they were being offered by an Italian company that was later purchased by ScanCAD. Currently, ScanCAD has an install base of over 900 companies in 42 countries. Systems are sold both directly by ScanCAD and under a variety of private label several OEM partners. ScanCAD systems are all PC-based, low-cost, easy-to-use systems. These systems are also multi-purpose with many applications that can be run on a single system by simply adding additional software modules. ScanCAD systems are designed to simplify the complex technology that is present in the PCB assembly environment. Most of you already know this, but the ceramic, fab, and assembly environment is very challenging. Designs are done by someone other than the manufacturer. Raw materials such as substrates, fixtures, screens, solder, components, etc. come from a variety of sources. There is a wide variety of equipment from many manufacturers that are used in the processes. Many processes are needed, including liquids, paste, glue, manual, automatic, etc. The people on the floor have a variety of skill levels and experience, and constant turnover can be an issue. Everything is getting smaller and smaller in size, and production runs are shorter with more changeovers. Everything has to be done in a clean, safe environment with no downtime, and done with zero defects. In a word, you are all magicians. Some of the tools you are using today are CMMs, calipers, microscopes, etc. These tools are very useful, but they do not provide you with the complete solution to all the problems that can be encountered when setting up new processes, changing over the line, or running an existing process. So, now you add to the equation tools that have not changed in over 30 years with the fact that you have to be magicians. Now, ScanCAD International is offering a revolutionary new product for pre-production process control. This product will assist you in improving the efficiency of new product introduction and product changeovers, maximizing the uptime of your line. Production can be simulated using actual parts, but it is done offline, overlaying all variables in a virtual environment. To be clear, this makes sure all the variables, such as screen, substrates with holes, printed substrates, placement data, etc., come together properly, and if not, perform any tweaking necessary before the parts get anywhere near the assembly line. How many of you have had lines sitting idle in the past because of an issue with a screen, a printed substrate, component, etc., or a new supplier, or simply a bad lot? Now you can make sure these problems are found offline, avoiding the costly downtime of a line, expensive rework, or warranty return. Now you may ask, how is this done? A revolutionary new tool from ScanCAD International. ScanInspect VPI, Virtual Product Inspection. The VPI system is a table-based system with a high-resolution scanning system located on a shelf below the table surface, so the scanner surface is flush with the tabletop. This allows for scanning very large objects such as stencils and frames. The system is very versatile with top or bottom lighting, color or black and white imaging. It is an accurate system utilizing a NIST-certified glass calibration plate. The resolution of the system is sufficient to inspect very small features. The system is in use today in production facilities, inspecting apertures as small as 50 microns or 2 mils. Presence-absence inspection of prototype parts with feature sizes down to 10 microns has also been done successfully. Programming of the systems can be done either by CAD, Gerber, or Golden Part. Now, with a single system, you can check virtually any stage of production. Check designs for manufacturability, including holes, slots, etc. Photo tools such as Mylar, Diazo, glass, chrome can be checked to make sure there are no issues once production starts. No more problems due to pinholes, scratches, etc. Substrates can be inspected versus Gerber data or a Golden Part. Check holes, via fill, and all printed layers. Inspect pasted substrates or perform first article inspection of populated substrates. Inspect screens and stencils, either incoming or after cleaning, to check for lifted emulsion, blocked apertures, damage, or stretch. The software has many layers, so you can overlay all steps of a process on top of each other to ensure all variables come together properly. In addition, the system can create data when none exists, or tweak data if it does not quite match. Create assembly data, including centroid data for parts. Create component vision files, no more calipers. Or even create or modify Gerber data for stencil, screens, or artwork. Make sure the stencil, screen, or artwork matches the part. These are some actual images from the VPI system. Please keep in mind the images may not appear as sharp on this video as they would on an actual system, since the resolution of the images on the video are not representative of the actual resolution of the system. Here are examples of LTCC, or thick film print, holes in substrates, paste or adhesive, emulsion screens, artwork, and loaded substrates. These are just a few of the many types of inspection that can be done with the VPI system. The VPI system can complement your existing measurement systems such as high-end metrology equipment. Measure a few representative features with the highly accurate metrology system and then inspect 100% of the features with the VPI system. It is possible to achieve an ROI of the VPI system with one production run. The systems are low cost enough that saving a single production error can pay for the complete system. Please remember that virtual problems are much cheaper than real problems. Now, let's see the actual system in operation.
Okay, we'll move now from the presentation and move into the ScanCAD VPI software. Right now you're looking at an image of a screen. We're actually zoomed in on the screen. Just to help you understand what we're looking at is the image on the screen. The green data is Gerber data. And behind the green data we have placed the actual emulsion screen, of which the software has the capability to do a color separation and extract the area to be inspected. So using the ScanCAD VPI software with an emulsion screen, we're able to actually come over and select the appropriate inspection level for this particular screen. Now I'll share with you that the traces that you see are approximately 3 mil or 75 micron. That's the trace width that you're currently looking at. The system in front of you right now is actually performing 100% inspection of this emulsion screen. In the lower left corner you can see a numbers counting down. Okay, it found 17 errors, and it actually numbers the errors, you can see in the lower left corner, from 1 to 17. So you can simply hit the letter N for next. It'll move you from error to error to error. At any point, if you want to look closer at the error, you can simply zoom in or even get closer. It is possible also to look at the color image of the board, and let's get even closer now to look at these errors. So you can see we have some missing emulsion between traces here. I'll move to the next error. Again, extra emulsion. If there's any question as to where the Gerber data is, you can see I can toggle that on and off with this system. So as you can see, each of these potential errors are situations that would cause concern. And here we have, as you can see, a piece of contamination. So this is just one example of the ScanInspect VPI system. Let's now take just a couple quick looks at some other examples. Moving now to a thick film example. And again, just a small image here. We'll zoom in a bit so you can see what this looks like. The VPI system is able to inspect the gold conductor print at the different stages of that process. It could inspect the blue dielectric or even the resistor print. Again, it's looking for opens, shorts, underprint, overprint. These are the types of errors that the VPI system can look for, all being compared back to Gerber data. We'll take a look now at another sample image. In this case, we'll take a look at a green tape example. Again, very simple, looking at some via. Let me turn this off here so you can see this. Here's a gold conductor print on a green tape material. So this can be used for via fill inspection, punch inspection, inspecting these traces. Very, very powerful system. Not only the same system that inspects the emulsion screen is the same system that inspects the print. Let's also now take a look at a stencil. We looked at an emulsion screen a second ago. Well, the same situation here. We have a solder paste stencil, which is used in the LTCC and hybrid area, and underneath that, well, actually the green data you see is the Gerber data, but underneath that we place the blue data, which is the actual, I'll zoom in a bit here, the actual stencil. Again, putting the two on top of each other permits us to perform an inspection. In this case here, we'll go ahead and run the inspection. And we'll zoom out and we'll see that there are 69 errors on this. So if I zoom into the different errors, again, we will see that we have a sample of different errors on this particular stencil. In this case, we have a situation where the stencil does not have apertures that match the Gerber data. So these apertures are either blocked on the blue stencil, or in case of a new stencil, they may not have even been there. In the case of this example here, we have a shift. I'll zoom out so you can see this. Here a device has actually been shifted. If this was a used stencil or emulsion screen, over time we all know that these tend to be stretched. And if the entire stencil image is stretched, then you would assume that we have some stretch and that could reach the point of failure. In this case, we notice that one device is okay, one device is not. So clearly we have a situation where there's been an error in producing this stencil. And then finally, we have an example down here of a BGA where we have a blocked aperture. So just giving you some examples of how the ScanInspect VPI system can be used. Again, emulsion screens, stencils, LTCC materials, thick film print, via fill inspection, punch inspection. Let me now share another example of die attach adhesive. If we take a look here, we will now zoom in on this image and we will get a little closer, and just sharing with you that the system does have the ability to inspect the adhesive coming out from underneath die before wire bond. Again, making sure that the minimum requirements are met. So this is yet another example how this system can be used. And again, I'm going very fast here for this presentation, but it gives you a feel for the different ways this system can be used. Let's jump into a loaded board very quickly. Again, a populated board, whether this be on a ceramic substrate, this happens to be an organic substrate here, but the system works exactly the same way. I will go ahead and now snap to this particular device. We can see this is R13. If I look down at the bottom of the screen, yes, this is R13. It has a 0 rotation. We can see the package ID is a 1206. The part number here happens to be a Kyocera part number, and this was placed on a Siemens machine. But again, in your environment, you simply have the ability now to scan in color and place a pick and place template, an actual placement template over the top of this. These could be wire bonds, these could be components. Again, the VPI system, the same system that does all this inspection, permits us now to do first article inspection of populated boards. Same system. For example, C7 here, again, 0 rotation. We can say this was placed on a Panasonic system. So that is an example of the loaded board. And finally, let's take one more look at a possible use of the ScanSpec VPI system for those of you who have wire bond. We'll go ahead and open up an example image here. And this is a very large image, so it could take a few seconds to load. I will share with you that this particular customer is inspecting over 15,000 wire bonds at the time of this inspection. And what we've done is we've just taken a small piece of this image to show you here. Yet the image is still large, but we're just going to zoom in on one piece. You can imagine how long it might take to manually inspect that many wire bonds, but in this case the system moves very, very quickly. Let me zoom out just a little bit here so you can see the wire bonds. We'll go ahead now and we'll perform the inspection. And we can see we have areas, 4 areas of concern here. And again, you can see on the screen that we do have a pad site with no wire bond. Again, these are numbered, so I can move from one to the next to the next. This particular example also shows that you can inspect for the pads themselves and the stitch, or we could be looking at, or the ball and stitch, or we could be looking at the wire itself. For our system, we do recommend that you look at the ball and the stitch. So this is yet another example of how this system works. Again, just being very quick, I will show the green Gerber template again on top of this that's been used for this programming. Okay, that gives you a very high-level overview and some images from the system itself. We'll now move back into the presentation.
ScanCAD International also offers low-cost production process control equipment. The most common form of inspection today in production involves the use of manual inspection by operators. Many of the same tools in use today for pre-production, such as microscopes, calipers, etc., are also used in production. It is typically not possible to perform 100% inspection using these techniques, and you are dependent on the judgment of operators, which is typically not repeatable. Another option is an expensive single-function AOI system. There are a few good systems out there, but it is not always possible to place these systems in every line due to the high cost. Another option is to not inspect at all and just to test at the end of the line. This can result in expensive rework and typically does not even catch all of the problems. ScanCAD offers a family of low-cost inspection solutions for production. These are multi-purpose systems and PC-based. Systems are available in both offline desktop configurations with manual load-unload or fully automated conveyorized inline versions. These systems provide direct feedback of inspection results. Find defects and either stop the line to find the root cause before further defects are made, or keep the line running and shuttle defects to a reject station for rework. A log file that can be utilized by standard SPC packages is also created automatically. ScanInspect API. Print inspection can be done to check for missing or excess conductor, resistor, or dielectric materials on LTCC, MLCC, or thick film substrates. The system utilizes golden board programming for fast and easy setup. Find print problems after printing instead of at the end of the line. Improve your yields and minimize rework. ScanInspect WBI. Perform 100% inspection of presence-absence of wire bonds. These images of 0.7 or 18 micron diameter wire show the powerful capability of the system to inspect extremely small features. ScanInspect SPI. Solder paste inspection can be done to check for the total area of solder paste deposits, amount of paste on pads, and bridging. The system also utilizes golden board programming for fast and easy setup. Find paste problems after printing instead of at the end of the line. And once again, improve your yields and minimize rework. ScanInspect ADI. Dispense or print inspection can be done to check for undersized deposits. Find adhesive problems after printing or dispensing instead of at the end of the line. This system is even lower cost than the SPI system. And ScanInspect BPI. Inspect for presence-absence of balls or bumps after printing. Inspection can be done either before or after reflow. Once again, improve your yields and minimize rework. So, in summary, ScanCAD process control tools can be used to catch virtual problems before the production floor, catch problems real-time before failure, eliminate rework, which is helpful to the environment, maximize your existing capital investment by keeping your lines running with full production versus using them to set up processes or troubleshoot problems. This obviously reduces the stress within your organization. No more surprises. Please contact ScanCAD directly or talk to your local sales representative for more information on ScanCAD products. Several other products not mentioned in this video are also available from ScanCAD. Some of these products are legacy re-engineering of PCBs, bareboard flying probe testers, inspection systems for other products outside of the electronics industry, such as fuel cells, photovoltaics, photochemical machining, and others. Software tools for minimizing EMI during the design phase of PCBs. Please see our website for more detail. This concludes our presentation. Thank you for your time and attention.